Okay, today we're going to be looking at simultaneous equations. We are going to be looking on the elimination method. We're going to skip the introduction and the objectives for this, but we're just going to go straight to what we mean by the elimination method, looking on the same. Alright, so with the elimination method, as the word elimination suggests, that basically just want to eliminate something altogether, bring it down to zero, bring it down to nothing. Basically that's elimination. So for example, if we are given say 4, now how would we eliminate 4 to bring it down to 0? Alright, first and foremost, we'd want to have a number the same size as 4, and that number would be definitely 4. So therefore these numbers are of the same magnitude, 4 and 4, and the signs are the same as well. So it's a positive 4, a positive 4. In that case, what do we do to eliminate that 4? Is to subtract. So we subtract 4 from 4 to ensure that we have 0. So what we looked at just now, in order to eliminate this 4 that we were given, we have to take a number from it that is the same size once the signs are the same. Alright, that is telling us that if the signs are the same, we need to subtract. So if signs are the same, we should subtract to eliminate numbers. So let's go on again, and let's now look on the continuous elimination method. And in this case we are given 2, but we are now given a negative 2, and we have a situation now where the signs and the numbers are different. And how is it that we now eliminate that these two numbers? Well, basically, if the signs are different, we need to introduce an operation, and it's by introducing addition. So therefore, if we have 2, we add the 2 to the negative 2. That would give us 2 minus 2 overall, which equals 0. So what does this say? This is telling us that if signs are opposite, or if signs are different, then we add. And basically we can try to do a little summary of this, in which case we say signs are the same, subtract. SSS for, some kind of acronym to help us to remember. If signs are different, then we add. SDA. So if signs are different, we add. So basically these are what we are saying. In terms of signs are the same, we subtract to eliminate. Signs are different, we add to eliminate. And now we are going to look on the first case here. Let's go back to the case where we are going to look on two simultaneous equations, a pair of simultaneous equations, in which case the signs are going to be the same. But there's another thing that we need to look on, and that's what we came here for. We need to emphasize that the coefficients must be the same too, because we have to ensure that the numbers were the same size in order to eliminate them. So therefore, same coefficient here is something we need to pay attention. Alright, so first step we want to do is to identify equation 1, identify equation 2, and then basically what we are saying here is that the number or the letter that have the same size number in both equations would be the one that we want to eliminate, because that means that they would have same coefficient. So therefore in this case x is being multiplied by 1 up here, and x is being multiplied by 2 here. So therefore we would not try to eliminate x. On the other hand, y is being multiplied by 1 in the first equation and also by 1 in the second equation. So obviously we would want to eliminate that y. So therefore now signs are the same. If the signs are the same, we are told that we should subtract. and so therefore equation 1, we are going to be subtracting equation 2 from it. So equation 1 subtract equation 2, and let's see what happens out of this. So just identifying that the signs are the same, so that means that it's going to be 12 subtract 15, which is what we get here. 12 subtract 15. And then on this side, y subtract y goes to 0, so that is left out. And then x subtract 2x will give us x minus 2x. So let's simplify this. That will give us a minus x. And 12 minus 15 will give us minus 3. And then from by through by minus 1 to ensure that we get x and not minus x. So that will allow us to get x equal to 3. And that's our first value of the simultaneous equations. Because when we solve simultaneously, we're going to get two values. So in this case, we have gotten x equals 3. So our first value is given. And now we need to use this value, which is to put x equals 3 into one of these equations. And more in this case, equation 1. And therefore, we write back equation 1. And we're going to put x equals 3 in for x. In what case, we replace the x with 3. And then now we try to solve this equation. We're going to take the 3 across the equal sign. When a positive 3 go across the equal sign, it changes sign and becomes a minus 3. So therefore y is equal now to 12 minus 3. And that gives us y equal to 9. Therefore, our two values x equals 3 and y equal to minus 9. So x equals 3 and y equal to 9. Sorry about that. X equals 3 and y equal 9. Now let's look at a case where the coefficients are not the same, but the coefficients are different. So therefore, these two equations. See, in the first equation, x is being multiplied. So let's label the equations. So equation 1, equation 2. Now, when we look on this, in the first equation, the x is being multiplied by 5 and is being multiplied by minus 3 in the second equation. Then here it's y is being multiplied by 3 in the first equation and y is being multiplied by 5 in the second equation. So in those equations, the coefficient or the number multiplying the variable is not the same. So the number multiplying the x is not the same for both equations, nor is it the same for y in both equations. So what do we do in a case like that? We try to find a way to ensure that both equations are being multiplied by the same. So in this case, if we decide to eliminate the let's identify that we are going to eliminate the x, and what we are going to do now in eliminating the x is to see what we must multiply the x in the first equation by and what we must multiply the x in the second equation by to ensure that both equations would have a number that is the same size. And obviously we would multiply equation 3 by equation 1 by 3. That would give us 3, 5, 15. And if we multiply, so we multiply equation 1 by 3. See, we did it right here. And now when we multiply equation 2 by 5 to make that number in terms of the size of the number is the same. We're not talking about the sign, so don't worry too much about the sign yet. The size of the number is the same. So that would give us the second equation to be multiplied by 5. Now 3 5s 15x, 3 times 3y give us 9y, and 3 times 25 give us 75. And now we would have to change this now to a new equation. I will call this equation 3. Similarly, we multiply the 3 by 5, so that gives us negative 15x. 5 times 5 here gives us 25y, and 5 times 19 will give us 95. Therefore, now we change this equation to equation 4. So now we have two set of equation. We have another pair of equation. given by equation 3 and 4, in which case the size of the coefficient for x in terms of the size of the number is the same, which is good for us. But we observe now that the signs are different, because the sign on this equation here is negative, right, this is negative 15. So this is minus, and the sign up here is plus. Now, when the signs are different, SDA, when the signs are different, we add the equations. So that's what we do here. So signs are different, we add. Therefore, 75 plus 95 will go here, right? And then that would be, now the 9y plus 25 will go here. The 15x plus negative 15x would be 0. So that is left out of this. So that evaluate, let's look back on that. 9y plus 25y would evaluate to 34. So we get 34y. 75 plus 95 adds up to 170. And therefore what we now need to do is to get y. And therefore the y is being multiplied by a number, 34. So the y is being multiplied by 34. The opposite operation to multiplying is dividing. So if we want to have y alone, we need to divide both sides by 34, which is what we do here. That becomes y by itself, and then 170 is divided by 34, which gives us 5. We can check these values. And then now we need to find the x value, since we have now found the y value. So therefore y, we need to put y equal 5 into, let's choose equation 1 from the first set of equations that we had, and that would have been 5x plus 3y equal to 25. We're going to substitute for the y. So therefore that means that we have to indicate that we're going to substitute there. So we replace the y with 5, 3 5s, 15. Then when we take the 15 across the equal sign, it takes on the opposite sign, so it becomes a negative 15. And that would be 5x equal to 25 minus 15 now. So therefore, we simplify to get 5x equal 10. 5 is multiplying the x, so x is being multiplied by the 5. So we want to get rid of that multiplier of 5, and the opposite operation to multiplying is dividing. So therefore we're going to divide both sides by 5, which is going to leave us with x, and the x will be equal to 2. Therefore our two values would be x equal 2 and y equal to 5.